Introduction to the Software Operation Interface. Open a file. Open a set of *.data test data files saved by the Phascan instrument. Click the File menu to open the data separately. View file properties and export current data from CLS scans. Click on the Report menu. Can export HTML web version and Word report. The relevant parameters in the Word report need to be set in advance in the Report Settings menu. The generated report storage path is the same as the data file path and is saved in the report folder in the data folder. The device can be connected to the device terminal for remote monitoring through a network cable or local area network. Preference can be saved and loaded according to personal preferences. Help. There are key instructions in the menu. You can view the introduction of relevant key functions in the keyboard. Processing parameters. You can view relevant parameter information in the current data. Click to open. Open a set of *.data test data files saved by the Phascan instrument. Report settings. You can choose to create a new report. Open top option. Straight through waves, straight shortcuts. TOFDBW straightening. TOFDLW removal. Synthetic aperture focusing technology. TOFD repeal. TOFD redo. TOFD defect length measurement. TOFD defect height measurement. TOFD defect depth measurement. Close TOFD option. Save defects. Chinese and English switch menu. These two are the automatic judgment reference exclusion areas. A certificate needs to be loaded later before it can be used. Aided analysis menu button. Screenshot button. Focus area refactoring button. Random gate button. Full screen display button. Line scan S_view straightening button. Scan axis moving slider. After opening a data, when we first analyze this data, according to relevant needs, this measurement value can be set appropriately. Then click on our measurement menu. You can also display these values in this text. Click the background menu to add this background. You can also look up the relevant measurements here. Context menu introduction. Combined with this NORI list of commonly used items, the quick menu is associated with the following menu. In the context menu, this skin sensitivity and surface compensation can be adjusted. Adjust skin sensitivity. The image can be changed. Then we choose the standard after. Change the skin sensitivity value. Defect equivalents vary with amplitude. Change the surface compensation value. The defect equivalent value will change accordingly. Does not vary with the curve. At this time, the defect signal will be amplified or reduced synchronously. Then click the gate. Different gates can be selected. Here you can adjust the starting point and width of the gate. Adjust gate height. It can also be viewed in the scan. Quickly adjust the starting point, width, and height of the gate. Click Area Reconstruction. It can also be used in our area. Or click the special shaped gate button. It can be reimagined. In C-Scan type, C-Scan can be replaced with top mode. The projection width can be adjusted in this mode. The scan mode can also be changed to top mode. In the Curves menu, you can click Show TCG Curves. The Standards column can be selected to select the relevant standards, or you can choose a custom standard. Quickly adjust skin bias, step bias, and steering angle in the location menu. Step bias is the distance from the front of the wedge to the center of the welding. Probe position can be quickly adjusted. If the position deviation is large, it cannot be adjusted. Scan offset. When there is an error in the scanning bias, you can adjust this value by perform a calibration of the two graph data. Switching the transition angle can change the probe orientation. Gate menu introduction. The gate type can be changed. Synchronization method and measurement method. When you need to open multiple sets of data. When top data fusion is required, top merge status can be selected. Turn it on. The data on both sides can be fused in the C-scan. The measurement method can choose extreme value, leading edge, peak value, etc. Select wave straightening mode, wave peak. This area can be handled. This is mainly for the scanning function of complementary foods. Sizing curves. You can view the TCG gain value at each point. Geometry menu. You can choose whether to display the thickness line. The thickness line is this whiteness dashed line. The thickness of the workpiece can also be changed by the roller. Click Welding Parameters. Welding parameters can be reset. Click on the advanced workpiece to load. Find the location of the workpiece drawings. Select the folder. Double-click to import this CD. After import, its step bias can also be adjusted. Click Restore to restore the original state. Measurement menu. You can view the relevant individual measurements. And relevant measurements can be set. You can choose to hide or show the marked defects. Display menu. Here you can choose layouts from different views. Hold down the left mouse button. This view can be viewed directly. Drag it into the display interface on the left to replace it. If the replacement is unsuccessful, you can shrink the software interface and replace it. You can switch the color ribbon here. Scan the data source to adjust this data. Position, generally used to analyze corrosion skin data. Amplitude, typically used to analyze welding seam data. Scan to source. Only works if there are two scan views. Scan shows all. It is generally used to analyze relatively long data, and it is only effective to open it. This data is relatively short. It is already in full display state. After turning it on, the image does not change. Scan reflection can choose first wave priority, last wave priority, or overlay. Scan 1-to-1 display. Usually it needs to be used with Scan reflection. Scan mode. You can choose Scan mode and D mode. Scan mode is one frame of image currently displayed. D-scan mode is an image superimposed between two cursors. Sean thickness settings. Used to set up corrosion detection data. Color ribbon display thickness range. Mouse menu introduction. Move the mouse over the B-scan and C-scan. Click the right mouse button. Different modes can be selected: data mode, trace mode, and cursor mode, etc. After selecting the data mode, double-click the mouse to move to view the data at the current scan axis position. When tracking mode is selected, after double-clicking the data, the cursor will follow the cursor axis. When cursor mode is selected, move only the measurement cursor. Right-click to choose whether to show or hide the cursor. Move the mouse to any view. Select an area in this view for image magnification. Right-click to undo this enlargement process. Move the dividing line in the middle of each view. Adjustable area size between views. Click to report. You can export reports in HTML or WORD format. After completing the defect analysis, click to report. Reports can be exported in HTML format. The report is stored in the folder of the current data report. Double-click to open the report for viewing. At the same time, the screenshot of the defect signal is also stored in this folder. Attention! When copying reports, you need to copy the folder where the screenshots are stored together. Otherwise, the defect picture cannot be displayed. When you need to export a Word report, report-related parameters need to be set in advance. Click OK. Then export the Word report. After analyzing the defective data, keep records of defects. When copying data, it needs to be copied together with the folder containing defect information. So the copied data also contains flagged defect signals. Welding Data Analytics PA. After opening a welding data, when first analyzing welding data, we are as needed can be set to display appropriate measurement values. Double-click to open the measurement list and select commonly used welding analysis measurements. Peak amplitude in data, a %. Depth of the indication in data, DA. Volumetric position in data on the index axis, via. Defect height UMR. Defect starting point SR. Defective endpoint SM. Defect length SMR. Max defect scan point, SMAX. Data echoes dB value compared to SL height. Zone of amplitude in data. Before analyzing the data, you need to choose the evaluation standards first. Data on both sides needs to be selected. Then, according to the comment habits, select an appropriate display layout. Then adjust the starting point of the gate, width and height, ensuring the integrity of data. You can also use the region of interest reconstruction function. Select the areas of interest and regenerate the Phascan image. Click the right mouse button to exit the concerned area reconstruction function. When using the region of interest reconstruction feature, the selected area needs to be within the gate range. If not within the gate range, the Phascan image will turn white. After adjusting the gate, then click to open the reconstruction function of the attention area. Box selected area reimagining. Right-click to exit. It can also be re-imaged using the profiled gate function. Boxes the areas that need to be focused on through a closed loop. Click the special shaped gate button to make a closed loop selection. Right-click OK. Closed loop selection of areas of interest can be completed. Right-click to opt out of this function. usually just boxes the welded areas after the software sets the parameters. The current settings will be saved by default. Next time you open the data, it will also be this setting. Before starting to analyze defects, you can first roughly observe the Phascan data image. Right-click on the data mode. Drag the scan axis to view the data. In the Phascan, the location of the suspected defect is found. Double-click the left mouse button to position the scan axis there. Simultaneous observation of Phascan view. Then analyze other locations. Observe for defects by moving the scanning axis. Found at this location. Defective signal. Move the scanner axis. Observe Phascan for defect analysis. You can see it at these locations. This location is not a defect signal. It is the welding height signal. Welding residual height signal, generally located on the opposite side of the welding center line. The depth is generally slightly lower than the double plate thickness line. In the Phascan, the welding residual height signal is generally relatively long. And I'm going to go to Scan A. You can obviously see the mountain-shaped echo. In A saccade, you can see similar multiple echoes. When the Phascan view is in angle mode, you can switch the angle line. Observe the signal image that suddenly appears in the Phascan. Double-click the mouse to locate the position and view this signal. After finding the defect can be measured. Let's start the explanation of manual measurement defects. It can be found in the Phascan. A defect signal appears at the position of the welding groove. First, we need to compare the data maps on both sides. It was found that the amplitude of this defective signal is relatively high in Group 1. Then choose to measure the signal in Group 1. Double-click the mouse to position the scan axis at the higher position of the defect echo. Through the left and right keys of the keyboard, find the highest echo location of the defect. After finding the highest echo position, press the Z key to record the position of the current highest echo. Then press the left and right keys of the keyboard. Locate the left and right endpoints of the defect. Here, the endpoint 6 dB method is used for analysis. Press the left and right buttons. Right-click and select Show Cursor. Click the right mouse button and select Show Measurement Cursor. Then the A and D keys of the keyboard are pressed respectively to mark the starting and ending positions of the defect. A defect signal is found at this location. An echo signal was found at the groove position in the Phascan. First, compare the signal amplitude of the data on both sides. It was observed that in Group 1, the signal had a higher amplitude. Therefore, choose to measure this defect in Group 1. Double-click to position the scan axis at the higher amplitude of the signal. Through the up, down, left, and right keys of the keyboard, locate the highest wave position of the defect. Press the Z key to record the current highest echo position. Then press the left and right buttons. By half-wave method or absolute sensitivity method, identify the starting and ending points of defects. This time, the endpoint 60 method was used to measure the defect. Click the left button on the keyboard. Find the position of half the wave to the left of the defect. At this time, press the A key to record the starting position of the defect. Then press the C key to return to the highest amplitude position. Then look for the end point of the defect. Press the right button of the keyboard, and in the process, it decreases and then increases again. Then the signal needs to end at half of the second highest amplitude. After finding the end position of the defect, press the D key to record the location. Click the C button to return to the highest volatility position. the starting point of the defect at this time. The endpoint and the length are measured. Press the up and down keys on the keyboard. Find the upper and lower endpoints of the defect. Press the up button to find the position of the defect half wave. Press the W key to record the upper position of the defect. Press the C key to return to the highest wave position. Press the keyboard down button. Press the S key to record the position of the lower end of the defect. At this point, the self-height measurement of the defect is completed. If the defect can see the diffraction signal of the upper and lower endpoints, then the diffraction signal of the upper and lower endpoints is the best position value of the upper and lower. The subtraction of the two values is the self-height of the defect. After the defect measurement is completed, press the C key. You need to return to the highest wave position. Click Save Defect again. Measurement of opening defects. Aim at this optimum occlusion position. Record the best reflection amplitude first. Then find the best diffraction signal position. After aligning the measurement line with the best diffraction signal and the maximum amplitude position, the subtraction of the values of the two measurement lines is the height of the defect itself. If the diffraction signal at the upper and lower endpoints cannot be observed, then you need to record the upper and lower endpoints of the defect separately. After recording the upper and lower endpoints separately, based on the plate thickness line, at a larger distance from the plate thickness line, as a defect its own height, it is observed that the measurement line above is quite different from the plate thickness line. At this time, the following measurement line should be moved to the position of the plate thickness line. The subtraction of the two values is the height of the defect itself. Then analyze the flaws behind this data. Found an internal defect signal here. By comparing, it is found that the signal amplitude on both sides is relatively low, below District 1. Then this defect does not need to be recorded. And then we found a defect signal. By comparing the amplitude of the data signals on both sides, it was found that the signal amplitude of Group 2 was higher. Then the defects are measured in this group according to the half-wave method. After pressing the Z key to record the highest echo position, then look for the left and right endpoints. Record left and right endpoint positions. After pressing the C key to return to the highest wave position, save defects. Defect measurement completed. After the analysis is completed, click Defect Report. You can view all group defects. Aided analysis defects. After finding the defect, auxiliary analysis capabilities are available. Conduct an auxiliary analysis of defects. This function is mainly used to assist in marking defects. It is convenient to determine the size of the defect. When using this function, first of all, we must choose a good evaluation standard. Then click the Auxiliary Analysis menu and then Product Classification, Item Category, Grading Method, and Recording Level. You can choose according to the actual situation. Click Confirm to enter the Auxiliary Analysis function. Defects are selected in the C-scan and S-scan diagrams, respectively. Attention should be paid during the box selection process. Defective parts should be framed. After the box selection is completed, click the right mouse button. Select Start Analysis. The measurement of defects can be completed. Pull the scanning shaft to observe the defect. If you need to fine-tune the defect size, it can be carried out on the basis of the original measurement. without fine-tuning. You can directly click to save the defect. When fine-tuning is required, double-click to locate the defect location. Press the Z key to record the highest echo position. The defect is then fine-tuned. After the adjustment is completed, press the C key to return to the highest echo position. At this point, you need to exit the auxiliary analysis. Click Save Defect again. After saving the defect is complete, the defect information of the original auxiliary analysis can be deleted. When analyzing a situation with multiple defects, click the right mouse button and select Start Analysis. Multiple defect messages appear at this time. Click on the defect list to view each defect. Then, according to the compound situation, click Delete, Merge by Standard, or Merge manually to process the data. The current defect can be merged. Data can also be modified, revoked, etc. Then delete the second defect. Defects can then be saved. Then we can continue to analyze the subsequent defects. Find the second defect. Finally, the test report can be exported according to requirements. The export and copying of reports can be carried out according to the methods described earlier. Introduction to Corrosion Analysis. After opening the data one by one, when using corrosion data analytics for the first time, the display of commonly used measurement parameters can be set. In the Measured Values menu, you can select the required parameters for display. Common parameters. Volatility a %. The thickness value is displayed in two cases. One is to not use the tracking gate. Select the. The other option is to use a tracking gate. Select a high. Index axis, IMR. Depth of corrosion pit UMR. The starting point of the corrosion pit SR. End point of corrosion pit S meter. Depth of corrosion pit SMR. Areas of corrosion pit F. In the display menu, you can choose from different layout modes. For cases where the tracking gate is not used, corrosion skin gate position, you need to select the gate position. In the case of using a tracking gate, then select the location of a high. When analyzing corrosion data, the gate measurement value needs to be selected as the edge. Ensure that the amplitude of internal defects in the workpiece can be displayed when it is lower than the bottom wave. After modifying the gate measurement method, in the color settings, you can also choose different display color ribbons. Then in the C-skin thickness settings, can be adjusted according to the actual workpiece thickness, maximum and minimum display thickness. After setting up, you can save this configuration. It is convenient to call directly when analyzing corrosion data next time. Next, start analyzing the data. Reposition the gate. C-skin imaging is expressed by thickness. Defect signals need to go through the gate to be detected. Some corrosion pits, if the signal amplitude is low and does not pass through the gate. If you raise the threshold at this time, the defect signal did not pass through the gate. The C-skin image will show red. At this point, the gate threshold needs to be lowered. Make sure that the C-skin image is displayed as a normal color and all signals can be picked up. The defect can be amplified in the C-scan. Then move the scanning axis left and right. Observe the condition of corrosion pits. Move the skin axis to the position where the corrosion pit is most volatile. Move the line of light to the lower end of the corrosion pit. Then find the starting point of the corrosion pit. Press the key to mark. Find the end of the corrosion pit in turn. Press the D key to mark. Press C to return to the highest wave position. The width measurement of the corrosion pit is completed. Then move the measurement cursor to the most corroded areas. Move to the bottom of a corrosion pit. The other line of light moves to the upper end of the corrosion pit. At this time, UMR is the depth of the corrosion pit. The depth measurement of the corrosion pit is completed. Then drag the vertical cursor. Measure the width of the corrosion pit. Move the two vertical cursor lines to the left and right ends of the corrosion pit, respectively. The measurement is complete. Click Save Defect. If it is necessary to directly measure the areas of corrosion defects in the Phascan view, you need to change the Phascan type to Top C mode. This allows you to directly move the measurement cursor. Measure the areas of corrosion defects. Move the cursor around the defect. Then the area measurement is complete. Then click Report. HTML reports can be exported. To export the Word version of the report, required in advance in the report template, set relevant parameters. Then the relevant reports can be exported. Click to export Word report. Complete the analysis of corrosion data, TOFD data analytics. Open ATOFD data according to the evaluation habits. Select a distributed view. There are upper and lower and left and right distribution patterns. Choose according to the actual evaluation habits. When analyzing TOFD data for the first time, relevant display parameters need to be set. Defect upper and lower endpoints TDR, TD meter. Defects own height TDMR. Defect start and endpoints SR, S meter. Defect length SMR. Before analyzing the data, it needs to be calibrated. In the B-scan, find a suitable location for deep calibration. Calibration is usually performed with a known pass-through, bottom, or known pore echo. Depth calibration is available in Calibrate and Calibrate with two depths modes. It shows up in the geometry. Calibrated and calibrated with two depths. Two reference signals can be seen in the spectrum, through waves and bottom waves. Optional calibrated with two depths. You can also select the two-wire calibration mode directly here. Enter the values for depth 1 and depth 2, respectively. Double-click the left mouse button. Put the red cursor. Moving to the first peak or trough of the through wave. Then click the middle mouse button. Move the green cursor to the position of the first trough or peak of the bottom wave. Right-click to complete this depth calibration. Then exit Deep Calibration Mode. If there is a defect in the location where the data fluctuates a lot, deep calibration can be performed again at the current location. Check the calibrated with two depths. Move the red cursor and then the green cursor. Complete calibration. Exit Deep Calibration Mode. Then analyze the length of the defect. Right-click to select Cursor Mode. Double-click the defect location. Fit the cursor curve to the left and right arcs of the defect. Determine the position of the left and right endpoints of the defect at this time. Then move the upper and lower cursors to the upper and lower endpoints of the defect. Move the scanner axis. Drag the upper and lower measurement cursors over. Make fine-tuning. There is a certain degree of defect. There are usually two distinct upper and lower end diffraction echo signals. Move the red cursor to the top of the defective diffraction signal. Then move the green cursor to the lower end of the defect diffraction signal. Record the upper and lower endpoints of the defect separately after marking is completed. Length, height, and sounding of defects. At this point, the measurement of the defect is completed. Then save the defect. Finally, click Report to export the report. When you need to export this word, report, after setting the relevant parameters in advance. Ray Export Word Version Report. Introduction to TOFD Enhanced Features with the left mouse button. Box select a local area for image enlargement. Right-click to restore. In the Geometry menu, the data processing mode can be selected as whole or era. When selecting whole, click on the corresponding function. Then select the area. The selected areas will be processed. For example, click the TOFDLW straightening. Click the TOFD repeal to cancel the operation. Click the TOFDBW straightening, regional debris straight. Click the TOFDLW removal, regional TOFDLW removal. Select whole. Click on the TOFDLW straightening, TOFD repeal. Click the TOFDBW straightening, regional debris straight. TOFD synthetic aperture focusing technology. The data processed by this algorithm. Length measurement can be performed using the N.6 decibels method to group TOFD data analysis. When performing two-set-TOF data analytics, two sets of data need to be calibrated separately. There is usually only one reference echo in this type of map. You can only see the through wave or the bottom wave. You can right-click to select the single-line calibration mode. After selecting Calibrate, set the depth to the corresponding depth value. Drag the red cursor for calibration. Here's a 100 plate thick but weld. The first area can only see through wave signals. Select Single Line Calibration. Set the depth to 0. Right-click to enter Deep Calibration mode. Then double-click the left mouse button. Calibration of pass-through waves. Click to exit through wave calibration mode. Complete the depth calibration of the first partition, then in the second partition. Again, right-click and select Single Line Calibration mode. Change the depth to 100. Place the red cursor at the first peak or trough of the bottom wave. Right-click to exit or click to exit Deep Calibration mode. Complete Deep Calibration. After completing the in-depth calibration, you can refer to the previous single set of data analytics methods. Finally, the defect measurement is completed.